So this is about an hour and a half after you all had lunch. Did everyone have a good lunch? Rub your tummy. Okay, so I am going to make you guys wake up. I do need to have all hands in the air. I am going to call out the people that don't do this. Go. Okay, you can put your hands down now. I will be asking for hands up about halfway through the session. It's not to wake you up again halfway through my session. It's actually because I'm after getting some feedback about where you guys think we are on 3D. Okay, let's go. So, quick run through the agenda. I'm going to have a look at data visualization, cartography, looking at the audience and intent. Also thinking about that emergence of 3D in the concept of, and in the thinking about data visualization using 3D. Have a play with space-time, animations, and then look at some of the tools and solutions and some of the things that enable us to do more of this now across and provide that to our users. Okay, so we've got new capabilities in visualization. We're able to visualize things in different ways. We're able to see underground. We're able to visualize assets underground. We're able to play with time in a different way than we have before. We're able to view reality in a different way. This growth in visualization options allows you to see what others can't. So we've had that shift for being able to do thematic and representational visualizations using 3D, and being able to play with time and query time in different ways. But my argument is that it's not about you. It's not about your ability to see things that others can't. It's actually allowing others or helping others to see what they couldn't before. So I'd like you to think about the new audiences. Who are your audiences out there? Are they the person in the field trying to do visualization in the field? What devices are they playing on? Are they your desktop users? Are they your executives, or are they your public users? Think about who they are in terms of their age, which generation they're from. Are they used to running around with a handheld device in their hands? Is this going to be more their norm rather than looking at a 3D paper map? And it's now possible to deliver a lot of these new techniques across your organization because we're no longer constrained to desktop applications. We're able to do a lot in the browser. So think about it from that visualization and communication aspect. So this is about the visualization science. Who are your audience? Are they users? Are they internal users that you're paying to actually sit at a desk and do their job? Or are they public users? What are the tasks they're going to be performing? Are they working with data that they know about and they're presenting that known? Or are they trying to explore and trying to discover new things about your data or about your assets? And what's the level of interaction that they're going to be doing? Are they going to be playing? Are they going to be panning around the map, doing a high level of interaction? Or are they just going to do a low level of interaction? Are they just going to look at what you produce, almost like you would do a paper product, and go, yes, that's nice, I can see what you're showing me, then move on to the next item. So this is a continuum from visualization, where you're doing that more exploratory action, all the way up to presentation, that traditional type of operation that we may have actually used for like a PDF document or a printed page. We've got new visual variables, and we've also got volume. So traditionally we had, for points, lines, and area, we had shape, we had size, we have different variants on color, we had textures. Now we've added in the new visual variables of 3D. So we've got 3D visuals and symbology. We've got the ability to extrude data and add perspective as well. And that's a different approach to actually looking at our data. And then on that volume side, we are actually able to represent real-world volumes now out in the browser. And then added to this, and able to mix up all of these, we've got the ability to animate some of these variables, to play with color in a different way, to animate in 3D. So, emergence of 3D, sort of, so what? Why is 3D important? I think one of the things I'd argue is that we're not flat anymore. We don't think of ourselves as living in flat communities. If you take a look around, the buildings that we live in now are often much taller than they have as a footprint. So actually just say taking a building footprint and representing that as a size, it really just doesn't count, because that building, as far as actually how much floor space it has, or how much volume it takes up in real world, is much, much more than it would be for a traditional where we're actually living in a, in a 1 or 2 story building. The sense of scale has changed as well. So when I first started out 20 odd years ago, if you were working at a map scale larger than 1 to 10,000, you thought that was really, really detailed. We're not working at 1 to 10,000 now. We're actually often working at much, much larger scales, 1 to 100. Not 1 to 100,000, 1 to 100. And at that scale, humans are visible objects on the map. So you can actually visualize humans and the way humans are interacting on a map, because you can actually, they've actually got a footprint, they've got a visual size in that. So, and then lastly, and this was coined by, I think, Nathan Shepard, says 3D gives you superpowers. 3D allows us to actually see inside things in different ways and explore the environment, and then go from that whole context view of a larger visual environment or larger urban environment, but then go up to an individual building and then start exploring inside that building. So this is going to be the interactive part. Most technologies go through an adoption curve where you actually start going from the innovators that start to think about things, through an early adopters, early majority, late majority, and then into the laggards. And I don't think anyone in Sydney or Melbourne put their hand up as saying they were a laggard, but we'll see if anyone does here. Okay, so I'd like you to think about how often you've played with that 3D, in the 3D space. So in terms of actually reality data, so reality measures, I'd like everybody to start with their hand up in the air. Everybody up? Okay. Put your hand down if you have never played with any 3D reality data at all. Okay. Put your hand down if you haven't played with any in the last 6 months. Okay, put your hand down if the reason you have played it in the last 6 months is because you were actually playing on Rob's stand out there. Okay, put your hand down if you don't have any 3D reality data in your organisation. Okay, so I'm looking around there. I reckon it's about a quarter, maybe quarter of you guys out there have got 3D reality data within your organisation now. I'll do this for one other. I'm actually going to do it for the mapping assets. Everybody put the hand up again. All your organisations have assets, believe it or not, even if they're the humans within your organisation. Okay, put your hand down if you have no 3D or Z dimension to your assets. Put your hand down if Z or 3D is not a key part of your asset management within your organisation. Did you capture about how many people that was? I think it's probably about a third again. Okay, what I'd say though is actually if you look out there, if I'd have asked the question 12 months, 18 months ago, 12 months or 18 months ago, I think I would have got very different answers. I think we've seen that uptake of 3D move. So we're actually, in terms of where we are on those adoption curves, I believe that we've actually moved across into the early majority in the 3D imagery, mapping assets, and in the urban planning space. I think BIM and GIS, a little bit disparate. In BIM is now pretty much mainstream out there in AEC. As far as actually that BIM and GIS adoption, I think that's still starting to migrate through the early adopters. So I think that's the thing that's still playing catch up. My views, tell me what you think afterwards. Okay, so reality capture, realistic models, and point clouds. Reality capture lets you see the world at a point in time. It's almost just like taking imagery. It's just instead of imagery without 3D, it's imagery with 3D. But we can use that as our base map, much as we would do for normal normal imagery. We can use it as our base map in our projects, so that we can actually visualize how assets interact with the real world. In that realistic sense, we can use text meshes to visualize the built environment and manipulate those. And point clouds, we can visualize very large, dense point clouds captured from LiDAR. So for those who, I think a couple of you might have actually played out on the stand there. This is some reality capture data provided by Aerometrics, but this could equally be data that you've flown yourselves from for a drone. I think this is from Aerometrics. I think this is Rob in the... Sorry? Yeah. Yep. So this one's actually, so this one's out, the railway workshops. Okay. For putting textures on meshes. So we're able to actually manipulate meshes out there and use texture meshes in different ways. We're able to filter out different textures. So in this case here, to highlight the commercial buildings, we're able to use that texture mapping, as well as a little bit of symbology and color, to actually highlight which are the commercial buildings in this environment. So manipulating 3D data in a different way to actually provide that visualization and highlight features. And then on the point clouds, this particular point clouds is about 1.6 billion features points, I believe. And we can manipulate how those are visualized. A little bit of tiling there. We can manipulate those the point clouds out there in the browser, but what we can also do has just come in is actually the ability to actually filter out some of the point clouds. So if you've actually classified in your point clouds, you classify different features based on your point cloud, you can actually filter those out from there as well. So in the 3D representational side, from the landscape, urban, and assets, we've had 3D available in the browser through the JavaScript API for about just over 3 years now. But what we're starting to see is actually full solutions being built by and provided by Esri around 3D. So in this case, this is ArcGIS Urban, when the session from Gordon later on. We're able to actually visualize a 3D urban landscape. We're actually able to play and manipulate, look at shadows and how shadows interact with the environment when you actually put a new project or building up. We're able to do things like, measure out there, measure the heights of buildings, get a bit of a sense of what's been built. And in terms of that superpower, we can actually view data in a way that you can't in the real world. So in your point of view in this case, we're able to use the slice tool to actually step backwards and see what buildings look like by excluding the buildings in the foreground. So we can actually get a better sense of what those environments, how buildings play in that environment. And then we can interrogate these 3D models and actually manipulate and get feedback on these. And that's one of the things that Urban provides, is that ability to do that feedback on new developments. When we actually look at buildings, we're actually able to manipulate. The layers that are there, so we can actually exclude different walls. We can use the slice tool to actually peel away part of a building so we can start looking inside of a building. So this is actually, I guess, this is beyond what we would have thought of as traditional GIS, where we're actually no longer thinking about maps and spatial as stopping once you actually get to the building size. We're actually starting to look inside buildings. And they are geographic entities. People behave in the environment. It's a 3D environment. It's still about geography, even if it's in the building. And then looking on that thematic view, using 3D data to present data thematically. So in this particular case here, we're actually using a 3D mesh to represent over time how this is crime data in part of New York City, where we're actually representing in 3D crime trends relative to the buildings and the landscapes that surround. And then another version of that is actually using semi-realistic objects. So in this case, they're trees, symbolized alongside their carbon content. So how much carbon they're storing in there. So we can use 3D thematically to present data in a slightly different way than we might have in the past. I mean, yes, you could have presented this in 2D. I think 3D is a little bit more immersive for this and actually might help us to understand that data a little better. And then the traditional thematic map where you symbolize everything by, in this case, poverty for different states or different counties. We can use 3D to actually extrude features based on a value. So this one's extruding features by their percentage of population below the poverty line. And then also using color as a second variable. So this actually gives us two visual variables that we can play with to actually be able to understand our data a little better. So taking a shift along, looking at space and time now. We've got more capabilities in time awareness within the platform. We're now able to do time filtering, or we're able to actually understand our data using temporal hotspot analysis, playing with space-time cubes, and using animation as well for this. And a lot of this is enabled by client-side feature layers, where we're no longer actually relying on ArcGIS Server to do all the rendering, but we're actually bringing features down into the browser. So feature layers now have supported for a couple of versions now. They've since I think 10.5, they've supported providing time info. So when you publish from ArcGIS Pro, if you put the time information into ArcGIS Pro when you publish, you have time and date fields in your server that know that is actually to be used for time. Time sliders get by default within the ArcGIS Online viewer. If you have a temporal layer, or a layer that's actually got time support, you publish it you actually get the time slider by default in the scene viewer. So you're able to filter areas by time, play animated, without having to do any additional work, without actually having to do any additional development work. You can actually filter that data out there. And this is showing road accident data over time up near Moreton Bay. With a little bit of sprinkle of JavaScript in there, we can actually go a little bit further. And this is time filtering by having all those features down here, we're able to interrogate features very rapidly. This is millions of points out there, and you'll see as you're panning around the map, we're able to actually identify those features. This is real time as you're moving your mouse around. You're able to query those layers within that area, and then you're able to filter those over time. And as we're doing that, we're filtering by time. That symbology is updating rapidly. It's updating as you're shifting that. So it's not like we're actually going a traditional approach where we might have created a filter and then we've gone back to the server, asked server to actually create a map image, come back, and you'd have that half a second lag while you're waiting for it to render. So those capabilities, by having features client side now, we can provide a richer experience to our end users. Space-time cubes. They're that 3D representation of analysis over time. We can use them to identify changes to hotspots, so not just going from that traditional hotspotting, where you're actually trying to find a hotspot in one area. It's actually trying to find out how that changes over time. And again, these are supported by feature layers, by having features client-side. So this particular one here, again, it's that Moreton Bay regional, area, and we're looking at actually the number of accidents. This is gridded up, number of accidents in a 5K grid area, and this is a space-time cube. So you think the ground is actually 2000, and then each month is another step going up in the Z value. So it allows us to understand how traffic accidents have changed over time, patterns in traffic accidents. And this particular case here, we can actually understand that actually there is variance over time in where traffic accidents happen, and that actually in some cases we'll see that there's been a reduction in traffic accidents over time. But as we go a little bit further back in that case there, just up the road, in the surrounding area, there's actually been an increase over the same time. So it's whether or not we've actually, by doing roadwork improvements, have we actually shifted a problem from one place to another? So these hotspots allow us to actually understand that data from a temporal aspect and see we can understand patterns in different ways. So behind this, we've got feature layers, and how we use feature layers is different now. And this is one of those things that when you come to publish data, consider how your users are going to be using the application and what they're going to be doing with it. So the traditional approach was you had the data, you publish that via ArcGIS server, and every time you panned the map around and moved around, it would go back to the server, print an image, and then display that in the browser. either in the browser or if you were actually using a service inside of ArcGIS Pro or ArcMap. The new approach with feature layers, you still got your data, you still got ArcGIS Server, but instead of bringing down an image, it's going to bring down those images in a compressed PDF file format, and those are going to come down as tiles. So it actually clunks up almost like your traditional map tiles. It clunks up the data into tiles of data. So when it makes those requests, it just requests those tiles that it needs to display on the map now. As you pan around, it's only going to pull those additional tiles down as you pan into those new areas of data. But all the rendering is actually now being done by the GPU. So what that means is that actually that dynamic rendering we were seeing before with those earthquake data, we can do that client side because we've got all that data down in the browser now. So I think that's one of the things that our different approach now with feature layers, with tiled feature layers, I think we've actually now, it just gives us a richer experience within the browser. Similar, a little different. From that, traditionally we would actually do, we'd actually often do a lot of caching of data and actually cache data as imaged as tiles in map services. And that, we'd cache that data and then we wouldn't be able to, we'd bring that data in, but we couldn't actually then filter out layers within that tiled map service. Now with vector tiles, and vector tiles have been around for about 2 or 3 years now as well, but we've seen that the uptake isn't particularly high. In fact, can I ask everyone to put their hand up if they're using vector tiles currently? I'm going to dip my head. Yeah, the uptake of vector tiles is really, really low, and it's a surprise because they are really, really powerful. I think we're just going to have to do some communications on vector tiles and what they support. I think maybe a directions live on vector tiles would be appropriate. So what vector tiles do is, again, they cache up the features as tiled data, but as vectors, bring them down to the browser, but you pre-cache those tiles. When they're in the browser, again, it's rendered by the GPU, and you can apply styles to those. Regenerating those tiles is very fast. So I think if there's any DNRME people in here, I think from memory, I think it was about 7 or 8 minutes to regenerate the vector tiles for the DCDB of Queensland. I'm just looking, sorry? Was it 8 minutes? Sorry. Okay. So about 8 minutes to regenerate all the tiles for all the parcels for Queensland. Whereas actually, if you were generating those as images, that would have been many, many hours. I'm guessing that would have probably been about 12 hours before. But once you've got them down in the browser, you can actually manipulate the symbology of those parcels as well. So one of the things that tools that are out there at the moment is there's actually a vector tile style editor. And this allows you to actually take an existing vector tile base map. And in this case here, when I'm actually using the world topographic base map. And without republishing the data, I'm going to change the style of this and then actually publish my link to my ArcGIS Online organizational account with the style and a reference to the data so that I can manipulate this and show this as a monochrome base map because I want to highlight certain features. But in this case, I want to play and actually use my roads as a certain color because I'm playing with roads data. I can then actually use that in my application without having to manipulate data, without having to store all these tiles myself. I'm just using someone else's tiles. But you can also use this with your own tiles. So if you had very dense asset data that you want to display rapidly within your map, you might actually render that at certain scales as vector tile data and republish that each night, and then allow people to actually turn or change the symbology so maybe if they want to actually display that as, okay, only show the water data or only show the sewer data. So you've got one tile cache, one vector tile cache, but you can actually symbolize that in different ways. I'd really encourage you to actually have a play at least with vector tiles. They are pretty powerful and they provide a very fast, rich experience for the user. So I'd like to come back to this slide again. Again, encourage you to start thinking about your audience, who you're going to be presenting this to, who's going to be using their data before using these visualizations. Are the visualization techniques you're going to use going to make sense to your audience? Are they going to get your message across well? is it the best methodology for doing that? Looking ahead, we've got more capabilities. We're increasingly seeing capabilities. They'll be developed and used in ArcGIS, be developed first in ArcGIS Pro, but actually they quite rapidly make that ability into ArcGIS Online and Enterprise. And they have to be in Pro first, because if you're publishing from Pro, am I getting thrown off stage? Okay. We've got updates to the ArcGIS Online and Enterprise viewers coming in the next few months. Experience Builder, which is a parallel product to Web App Builder. This gives a richer experience for actually building your own applications. Voxel layers for geometry, for geology data in the browser. That's currently supported in ArcGIS Pro. Animated symbols, texture meshes. I'm getting thrown off, aren't I? Okay,
Not
I'll
yet.
slow down then.
You're still good.
Am I still good now? Dynamic feature clustering, 3D meshes of the ground. On the resources, I've just got one link up here, which is pretty easy to remember, as long as you can remember to spell visualization with a Z. But if you go to developers.arcgis.com and do a search for visualization with a Z, there's actually some great reference sites and great examples there of how to use of different forms of data visualization techniques. On the training front, ArcGIS Pro, a lot of visualizations, even if you're going to publish them later, you've got to do through ArcGIS Pro. I also encourage you to have a look at getting started with Insights for ArcGIS. That's got some data visualization techniques. And then in terms, there's a free cartography MOOC. I think it's probably going to be offered again. The next one's in May next year, which will allow you to actually shows you some of these new cartography techniques, data visualization techniques using Pro, and that runs over 6 weeks. It's 1 hour, 1 or 2 hours worth of learning once every 6 weeks. I think that's me.